Hello everybody and welcome to this channel. In this video we'll be discussing how to balance redox reactions. Now if this is your first time of watching this video, I have made a separate video already on the overview or the introduction to redox reaction, where I explained what the redox reaction means and how to determine the oxidation state of atoms in a compound. And also I talked about how to determine whether a reaction is even a redox reaction or not, and how to determine an oxidizing and reducing agent, which are somehow confusing. I explained all that in a separate video, so I would advise you to watch that video first, and I will drop the link to that video in the description section of this video. And also, if this is your first time of watching this video, make sure you subscribe to this channel. More educative content are coming up and they are all free. All you just have to do is to subscribe to this channel and like this video. And also don't forget to share with your friends, your course mates. Share the link to the department group as well, so that everybody can benefit from the video. It's absolutely free. Now let's get to the main topic. So how do you balance redox reaction? Now you must realize that you can only balance redox reaction in some media, like maybe in acidic medium. They can ask you to balance redox reaction in acidic medium. You can be asked to balance it also in basic medium as well. So I will start with how to balance redox reaction in acidic medium. Now let's say we have C2O4 2 minus plus MnO4 minus to give Mn2 plus CO2, and you're asked to balance this redox reaction in acidic medium. How do you do that? Now you must realize that there are some set of rules to follow to balance redox reactions in acidic medium, and there's also another set of rules to follow to balance it in basic medium. So the first rule is that you should write down the half equations to show the species that are oxidized and that are reduced. Now notice that we're having carbon and oxygen here, we have it here too, so definitely this should have given rise to that from here, 2 minus to give CO2, and also MnO4 minus to give Mn2 plus. So we have MnO4 minus to give Mn2 plus. So from here you can calculate the oxidation state of manganese, and that's going to be +7 according to the video I made. So I explained how to do that. So you get +7 from here, and this is +2, so that's reduction and oxidation number, so that's reduction. So this is a reduction reaction, and this is obviously oxidation reaction. If one is gotten to be reduction, definitely the other will be oxidation. Okay, so now don't forget, why we are splitting them is that redox reaction, they happen at the same time. We have reduction and oxidation in the same reaction because they follow each other, they do happen together. So after you've separated this out, oxidation, reduction, the next thing is to balance all the atoms except oxygen. So you first balance all the atom other than oxygen. Then after you balance all the atom other than oxygen, you balance oxygen next. Then after you balance oxygen next, you balance hydrogen. So it's like this: other elements followed by oxygen, then followed by hydrogen. So let's start from the oxidation half reaction. So this is the oxidation half reaction. You will notice that we are having more carbon here than here. So to balance it, the best way is to add 2 to this side, and at the same time you have also balanced oxygen. Now the only difference between balancing redox reaction and normal reaction, another reaction, is that you also have to balance the charge, because as you can see from here, you are seeing some charges here, so you must also balance them as well. So after you've balanced all the atoms, now the next thing is to charge. Now to balance the charge, you use electrons. Now you only be adding electrons to some side, not removing it. So you're having -2 overall charge here, and here you're having 0 because there's no charge. So to balance it with electron, you must add +2e minus. 2e minus now has given this side -2, which is now equivalent to this side. So you have successfully balanced the oxidation reaction. Now to balance the reduction reaction, you do the same thing. First, you need to balance the manganese, this one, which is MnO4 minus to give Mn2 plus. So we have more oxygen than oxygen we have here. So what you will do is that to balance one oxygen, according to this rule, you add one H2O. Now you want to balance 4 oxygen now. So here is deficient of oxygen. Instead of you to add 4 oxygen, you add 4 H2O. And of course, you have balanced it because you have 4 oxygen here now. Now at the same time, you have increased the number of hydrogen here. So subsequently, you have to balance hydrogen at this side. So to balance one hydrogen, use one H plus. Now we have 8 hydrogen here. You should add plus H plus. Don't forget, you don't add H2. You don't add H. You only add what? H plus. So you have balanced the atoms in this reaction now. So the next is to balance the charge. -1 plus 8. Because you're having 1 plus here, but we're having 8 of them, that will be plus 8. So the total charge here is plus 7. Now over here, the total charge here is just plus 2, then plus 0 from the water. So the total charge here is plus 2. Now you can only add electron, as I said. So that means that to balance this charge, if you add electron to this side, maybe you add 2 electrons, that will be 2 minus 2, that's 0. If you add 2 electrons to this side, that will be 7 minus 2, that's plus 5. Then if you add plus 3 electrons, you have plus 4. If you add plus 4 electrons, you add plus 3 at the end. So you are going to plus 2. So definitely you should add 5 electrons to this side. So if you add plus 5 electrons, so plus 5 electrons, then you have plus 2 charge over here, which has now been the same as the other side. So you have successfully balanced the two equations atomically and also charge wise. So you have balanced the charge and also the atoms. Now according to oxidation reduction reaction, oxidation is loss and reduction is gain of electron. Don't forget the mnemonics I made in the video. Oxidation is the loss of electron and reduction is the gain of electron. So the number of electron lost in the oxidation must be equal to the number of electron gained in the reduction. So here we are losing 2 electrons, here we are accepting 5 electrons. So you must make sure you make them balance. One of the way of solving this kind of problem is that you multiply this first equation by the coefficient of the electron we are having. And also you multiply this equation as well by the coefficient of electron we are having here. Now to do that for equation 1, the coefficient of electron we are having here is 5. So that means that you multiply equation 1 by 5. You end up having 5C2O42 minus to give 10CO2 now, because you're having 2 here times 5, then plus another 10E minus. Let's say this is equation 3. Then you multiply this equation by what? By 2. That will be 2MnO4 minus to give 2 plus 16H plus, this times 2, then plus 10E minus to give, I multiply this by 2, that would give 2Mn2 plus, then plus 8H2O. That's another equation 4. So after that, after you have balanced and you make sure that the number of electron lost is the same number of electron gained, so you make sure that you now add all the equations together. So if you add it reactant wise and product wise. So that will be 5C2O42 minus plus 2MnO4 minus plus 16H plus 10E minus to give 10CO2. I've now reached the product, then plus 2Mn2 plus 8H2O, then plus 10 electrons now. So you can see that this electron can now cancel this electron over here. So you end up having a result as if they are not there again. So just remove them. That's all you have. And this is the balanced redox reaction for the first reaction written. Now let's look at another reaction. Let's say we have for instance, we have N2O4 plus bromide to give NO2 minus plus BrO3 minus. Let's say we have this reaction. So we know that the N2O4, this should be capital O, to give NO2. And we know that it's the Br minus that will give the O3 minus. Now which one is oxidation and which one is reduction? So this, of course, from -1, bromine is having -1, and bromine here is having x minus 6 equal -1. So x equals 6 minus 1, so that's equal +5. If what I've just did here, what I've just done here is not clear to you, you can revert back to the video I mentioned in the introduction. So you'll see the link in the description. So bromine is having +5 here and it's having -1. So that's increase in oxidation number. So that's what? Oxidation. And here it is reduction, obviously. You don't need to calculate anything here. So it will definitely be reduction. But you can confirm. Oxygen will not change, but nitrogen will change here. That's 2x minus 8 equals 0. So x equal 4a. Then a x also equal x minus 4 equal -1. So x equal 3 minus 1. 4 minus 1, that's 3. So from 4 to 3, that's reduction. So now how do you balance it? So let's start from this reduction half equation. So nitrogen is not balanced, so you balance that. To balance that, you put 2, and at the same time you have balanced oxygen. Now let's use one hand to balance the electron to the charge. So the charge here is -1, so here is 0. So to add E minus, so you have balanced it now. Let's call that equation 1. So you have balanced it. The only thing that can change in this equation is the number of electrons. If the number of electrons lost in the other one is not the same as this. So let's try and balance for the other one. That would be Br minus to give BrO3 minus. So you want to balance 3 oxygen here. That will be plus 3H2O. Don't forget, to balance 1 oxygen, you add 1 H2O. Now you have 3 oxygen, that's 3 H2O. Also, you have increased the number of hydrogen. So that means you have to balance it here with what? 6H plus. So we're having 6 hydrogen here. To balance it, you use H plus. Don't forget, that's the rule. Then at the end, so you have -1 plus 0, that's -1 overall charge A, and that's -1 plus 6, that's +5A. So to reduce +5 to -1, you must add plus, if you add +4 electron, that would be 5 minus 4, that's +1. If you add +5 electron, that would be 5 minus 5, 0. Definitely you should add +6 electron, so that would be 5 minus 6, that's -1. So +6 electron. This will balance the equation charge wise. So we now have equation 1 and 2 now. So obviously you can see that we need to multiply equation 1 by 6. Okay, because the coefficient of electron in equation 2 is 6. So you need to multiply equation 1 by what? By 6 electron. Don't be confused with this. This is just to label it. So you multiply equation 1 by 6 and you multiply equation 2 by 1, because the coefficient of electron in equation 1 is 1. So you multiply equation 2 by the coefficient of electron in equation 1. So to do that for equation 1, you have times 6. That's 6N2O4 plus 6 electrons to give 12, right? NO2 minus. And here we have times 1. So you still remain the same equation we had earlier on. So we have BrO3 minus plus 6H plus 6E minus. So what we just need to add now after the number of electrons has been the same is just to add them together. 6N2O4 plus Br minus plus 3H2O plus 6 electron to give 12NO2 minus plus BrO3 minus plus 6H plus 6 electrons. So these electrons now, they cancel. We have this cancel this now. So the equation now becomes 6N2O4 plus Br minus plus 3H2O to give 12NO2 minus plus BrO3 minus plus 6H plus. So this is the balanced chemical equation in acidic medium for that reaction. Let me give you one more reaction as a little bit harder than this. So let's say we have KMnO4 plus iron sulfate to give MnSO4 plus iron sulfate plus K2SO4. Now normally this doesn't have charge, so if you want to do it, you have to separate it. This will be given as KMnO4 minus, you split them. Now this will split to ion 2, then plus SO4 2 minus. Then to give this will slip to Mn2 plus, then plus SO4 2 minus, plus, now this will split to, we have 2 of iron, right? Then it will be ion 3, plus we have 3 of sulfate, that will be SO4 2 minus, then plus 2 of potassium plus SO4 2 minus. Now notice that we are having potassium here and it doesn't change as well in the product, so we're having potassium as well, right? We're having SO4 and also it's still like that again in the product. So that means that one doesn't change in the reaction, it doesn't undergo any reaction. So they are called the spectator ions. Spectators ion. Spectator ion. You just come to the reaction to come and look at how everything is happening. They don't actually participate in the reaction. So how the one that are actually partaking in the redox reaction, that is the one that are actually changing, is this, then plus the ion 2 plus to give Mn2 plus plus the other one 2Fe3 plus. So those are this is the main redox reaction for this reaction. Now this is the main redox reaction that you need to balance. So to balance that, you can proceed with the normal way. So you just separate them from MnO4 minus to give Mn2 plus, then from Fe2 plus to give 2Fe3 plus. Now sometimes, if you want to balance this to be 2, right, you add 2 to this to balance the atom. But that's why sometimes you don't need to write it, because at the end they will still cancel. If you divide both by 2, so this will still cancel this. So you don't need to deceive yourself again. So just leave it as Fe2 plus goes to Fe3 plus. So this, of course, oxidation, increase in oxidation number, and this will be reduction. And in fact it is, because this is plus 7, this plus 2. Now you have to balance this normal way. So you balance the first one, MnO4 minus, to give Mn2 plus. To balance the oxygen, you add 4 water, because you have 4 oxygen to balance, then plus 8H plus. So we're having plus 2 here, we're having plus 7 here, add 5 electrons. And to balance the other one, you have Fe2 plus to give Fe3 plus. Plus 2 plus 3, add 1 minus A. Okay, that's balanced. So you just have to multiply this equation by 5, because we're having 5A. So I need to become 5Fe2 plus to give 5Fe3 plus 5, then plus 5 electrons. You multiply this equation by the coefficient of electron here, which is 1. So you still have this equation again. So you now add them together. Now you have so let me know what you have here when you add them together in the comment section. Now also, don't forget, all these are what balancing in acidic medium. So how do you balance in basic medium? So there's some set of rules for that, but I will not be talking about the rule. There's a particular shortcut you can use after you have balanced in acidic medium. Don't forget, you can do one shortcut here to balance in basic medium, and that is by, for acidic medium you should be having H plus. That's the characteristic of acid. So that means that for basic medium you should be having OH minus. So what you will just do is that add the same number of H plus you have, add the same number of OH minus there. So that will be 5C2O4 2 minus plus 2MnO4 plus 16O. Sorry, it will first be H plus that we add. It will be 16H plus. Now you now add the same number of OH minus. That will be 16 OH minus. You add that. Then to give 10CO2 plus 2Mn2 plus 8H2O. Now don't forget, if you do something, because it's equation, to make it balance, you must do the same thing for the other side as well. Now don't forget, if you're having H plus OH, that will give you H2O. H plus OH, that will give H2O. So we have 5C2O4 2 minus plus 2MnO4 plus, it's having minus plus 16H2O now. Because we have just one H plus one OH, you can have H2O. Now if you have 16H plus 16OH minus, you have 16H2O now, to give 10CO2 plus 2Mn2 plus 8H2O, then now plus 16OH minus. So you notice that we are now having OH minus. Now that signifies that it's a basic medium. So you can reduce it. We have HH2O, we have 16H2O. So that will reduce by the time you subtract 8H2O from both sides, so that you can cancel the H2O at the right hand side. So this becomes 8H2O. Now if you remove 8, alright, 10CO2, then plus 2Mn2 plus, then plus, you have subtract 8H2O from both sides, so this becomes just 16OH minus. And this is the balanced chemical equation, the balanced redox reaction in basic medium. Don't forget, this is the what? Balanced redox reaction in acidic medium. So just like a 3 steps from that, and you get your basic medium. Alright, so now for this one, let's balance it in basic medium as well. So that will be 6N2O4, then plus Br minus, then plus 3H2O, to give 12NO2 minus plus BrO3 minus plus 6H plus. Now you add plus OH. I've made a mistake, sorry. Alright, so it will be plus 6H plus, and you add equivalent amount of OH. Then also to this side too, you should add 6OH minus. So you have 6N2O4 plus Br minus plus 3H2O plus 6OH minus to give 12NO2 minus plus BrO3 minus plus 6H2O now. Now we have 3H2O, we have 6H, so subtract 6NO2OH, sorry, O4 minus. Now you now subtract 3H2O from both sides, so you now have plus 6OH minus A, then to give 12NO2 minus plus BrO3 minus, now plus 3H2O, because you have subtracted 3H2O from both sides. So you end up having this. So this is the balanced redox reaction in basic medium for this reaction, because we're having OH now, not H plus again. So that's going to be the end for this, and I want to give you a task. I want you to finish this, complete this, and get it in acidic medium, and use that method to get for it in basic medium as well. And make sure you comment your answer in in the comment section below. If you cannot type it, you can just write it down in your note and snap it and show it to me, and I will respond to you. Also, if you need some other questions as well, I promise to send to you. Just message me on WhatsApp 09026110060. So that's like +234, then 9026110060. I would send you some practice problem on this redox reaction. I promise to check your answer to guide you whether they are correct or not. So also, if you are interested in our tutorial that's taking place in University of Ilorin campus, the physical tutorial, you can also message this same number to join us. Yeah, we have many courses, CHM 101 and 115. We have physics as well. There are physics courses like 115, 191, and even 125. And we have CSC, and we have some other courses as well. You can just message on WhatsApp, and we are going to guide you. Just tell us your department, your level, and your name, and the list of courses you want to register for. The tutorial is currently ongoing if you want to join us. So that's going to be the end for this tutorial. Thanks for watching, and make sure you like, subscribe, and share with your friend as well. Thanks for watching. Bye.